Okay, so here we go with the first example video for this basic u sub problems. So I have 3 examples here because they're not too bad, and as always, please pause the video and try them on your own. Look at the example we did at the intro and do whatever you need to do, but try them first. And I'm assuming you have. So what I'm looking for, if you remember, is I'm looking for some function which is anywhere inside the integral, and the derivative of that function has got to be being multiplied by the rest of it, because that's what a derivative looks like once you do the chain rule. So remember, this function here is what I let u equal. So let's do the first one. I've got u equals, what do I see? I see x to the 4th minus x is here, and the derivative of that is exactly 4x cubed minus 1. So that original function, it doesn't matter that this is to the 6th. That original function can be anywhere inside. So that's what I'm going to let u equal. It's my original one. My du dx, that's 4x cubed minus 1. And then my du is 4x cubed minus 1 dx. This is what I'm looking for in the integral to cancel out and replace with du. So now, what is it? I get the integral. Sorry, I erased a 6 here by accident. X to the 4th minus x is u. So this whole thing is u to the 6th, underlining in green. And then in red, I've got 4x cubed minus 1 dx. That's exactly du. So I can cancel those out and write du. Perfectly doable integral. What's the integral of u to the 6th? It's u7 over 7 plus c. And that's, I can just sub this back in. X to the 4th minus x to the 7th over 7 plus c. That's it. For the second one, see again, I see a tangent in here, and the derivative of tangent is secant squared. Secant squared is being multiplied by the whole square root, so I'm good to go. So I'm going to let u equal the original function, but I'm not going to let it be tan x. I'm going to let it be 1 plus tan x, because the derivative of 1 is 0, and I can just, if I can get rid of more stuff, I might as well. So that's what I'm going to let u equal. Du dx is secant squared x, which means du is secant squared x dx. So now I can transform this. I've got the square root of what? I've got the square root of u. And then in red, I'll put in my secant squared x dx. That I can just take the whole thing out and replace with du. Off to the side here, I'll figure out what that integral is. The integral of root u, that's u to the 1/2. And with integrals, I add 1 to the power, so a half plus 1. Then I divide by the new power. And dividing by 3/2 is the same as multiplying by 2/3. So I've got 2/3 u to the 3/2 plus c. And I can just sub this back in. I'm running out of room here, but u was my 1 plus tangent x. And that's it. Third example looks really gross, but I do see ln x and 1 over x. It's got to be something that can cancel out. So what am I going to let u equal? I've got a function here. It appears more than once. That's even better. And then its derivative is all the way on the outside. So that's what's going to be my u. I'll actually write it over here so I don't run out of room. U will be my original one, and du will be 1 over x dx. Sorry, I should write that intermediate step. And and then du, that's when I can multiply on both sides. So this integral, I'll take care of my just the function first. This whole thing is just u to the fourth, because u is ln x, minus 4u squared minus 10u. And then this 1 over x dx, I gotta get rid of. That's just the same as du. I do that u over 5 minus 4u cubed over 3 minus 10u squared over